Welcome back to data science class. This is one of the most important topic we'll be covering. This is about object oriented programming. Hi, this is Vivin Arana. Let's talk about object oriented programming. Object oriented programming is your programming around objects. That's why it's called object oriented programming, of course. But what it does actually mean is it kind of defines the functions in a way. It defines the objects or anything that you use inside your coding in such a way that it feels more realistic to real life than the procedural programming that we've been following before. So what happens in object oriented programming is everything is defined using a class. So you kind of architect everything with a class. As they say, class is a blueprint and the object is something that you created from it. Now it makes sense if you hear it quite a lot of times. If you think of construction case, the blueprints that they have to build a house doesn't actually is a house. It's a blueprint. It's a flat paper. When you actually build the house, that's where the object is from, and you build the object from the class. So class is nothing but just a definition, whereas the object is the actual object that exists in memory. You can think of it as, let me give another example. You can think of it as a recipe. A class is a recipe. You can't eat a recipe, but with that recipe you can cook some food, and that is an object, something that exists in real life. I think that makes more sense. So a class is nothing but a recipe, and object is the food that you cook from that recipe. So let me give you some example. Let's go ahead and create a new notebook. And to start for class, I'm going to say class and give an example of food. I'm making a class called as food, and inside a class, what does a class actually contain? A class contains properties and behaviors. What are properties and behaviors? Properties are nothing but they are variables which tell me what type of food it is. For example, I can say cuisine. I can say how spicy it is, level of spicy, how much time does it take to cook, how many ingredients does it have. So those are properties of a class. And behaviors are nothing but functions. Functions like, okay, serve the food if it's ready, eat the food if it's ready. So I'm going to create a few behaviors. So I'm going to say cook food, and behaviors are function, and it takes an object of self as a parameter. So this is a basic definition of how you write a class, and inside this function will, let's say, just a print cooking food. So that's my first function. I'm going to write another function. I'm going to say eat food, and you pass the object print, and I'm saying eating what I cooked. So this is a very simple class that I've created. Now why do I have to give this self? The thing is, I need an object to pass when I need to call a function, because you can't, as a class object, if an object doesn't exist, you can't run a function from that object. So what I'll do is I'll create an object. I'm going to say f1 equal to food. What this does is it will create an object f1 from this particular class, and it will call it food. Now if I call cook food method, it will run that and will call that function and print it out. So you don't have to pass anything inside here, because it takes this object as an argument and prints it out. Similarly, I can do f1 dot eat food, run it, and there you go, it prints out, it runs that function. If I create something different variable and try to call this, if I say a equal to something, it's a string, it belongs to the string class. So if I say a dot cook underscore food, it will not work because it doesn't have a function inside the string class which is cook food. It will only work for objects that are created using this class structure. So let's go ahead and set some more objects inside here. So I'm gonna create again class food, and I'll say I want to define set ingredients. So what I'm doing right now is I'm setting different properties. So I'm saying that this particular food has ingredients. So if I want to set ingredients, that means someone, whenever you create this food object, you are going to create, are you gonna send some ingredients to it. So I'm gonna say number of ingredients, let's call it number of ingredients that we have. The way you define and the way you assign it, you say ingredients. If I spell it wrong once, I should spell it wrong as many times as possible, right? So I'm just going to copy and paste it. I'm going to call another function. I'm going to say set cuisine. What cuisine does it belong to? Self cuisine. So these are all the different properties of these. So if ingredient is a property of food, cuisine is a property of food. So I'm going to say self dot cuisine. As I said, if I mistype it once, should do it again. And next one is, let's say, show the number of ingredients it has. This is a behavior message, so I'm not gonna add anything to it. Return. Oops. Self dot ingredients. I think I copied. Okay, so there you go. I have that. Similarly, I can do the same thing for cuisine. I can say show cuisine, so it can tell what it is, and I can also have these functions that I've created before added to it. So I have my entire class with bunch of different ingredients, and it has some behaviors like cook food and eat food. So let's go ahead and create a food object. Okay, now I have that. Now to set the ingredients, how many ingredients it has, you can do set, call this function, I'll copy this, say this has 10 ingredients. I can say f2 has, what cuisine does it belong to? I'm gonna say this is Thai. And now if I want to, let's say, see the output for what all ingredients it has, I can do f2 dot show ingredients. It has 10 ingredients, which is right. f2 dot show cuisine, should say Thai. Perfect. f2 dot and the other functions, and forgot the brackets, and f2 dot eat food function. That should work as it is, and there you go. So it works everywhere for it. Now instead of doing this, of setting ingredients, setting cuisine, you can use something called as constructors. Constructors are nothing but when you create an object, like in here, you can actually pass some variables like ingredients, Thai, cuisine, all these things. You can pass it while you are initializing a particular object. So for that we can use something called as initializers or constructors. So let me take my, let's create a new class altogether. Enough with food, so I'm going to go with cars. It kind of makes me hungry when I talk about food too much. I'm going to create an initializer. The way you create initializer is 2 underscores init underscore underscore, give the self object. Next, let's say I want to give year, make, model and color of my car as the parameters. Now I can say to assign this. So this is how you write a constructor, where you can pass all the variables that you want to set while you're creating this this particular objects from this particular class. So I can say self dot year equal to year. To repeat this, make model, let's say make model and color. So this is how you can, when you create a class of car object, you can initialize all these variables and it will be available for the object. Now let me just say display car details. Let's create a function, and inside this pass self, and in here I can say print car is self dot here, so it will print me what year it is, what is the make, what is the model, and what is the color of this particular class. I'm gonna go run it. So this class is created. Now I need to create an object for this. So I'm going to say c1 equal to car. I'm going to say it's a 2004, so year. For year I'm going to give 2004. For make, I'm going to say, let's say BMW. I'm going to say make, model X5, make is BMW, model is X5, color is red. So I created that. Now if I say c1 dot display car details, I will see car 2004 BMW X5 red is what object that I've created inside c1. So that kind of gives me an idea of how you can use initializers and initialize the entire object just with one line while initializing, and then use the behaviors or functions to do whatever you want to do instead of doing set again and again. You can use combination of both too, but this is much more easier when you're building it. Next thing that I want to talk about is inheritance. One of the very important part of building classes. So let's say I want to create a car and I want to give it basic functionalities like all these things, but then I want to also create a class called a sports car and an economical car. So there's two different classes. Both these cars, let's say economic car and sports car, both have the same functionality of a car. They all have a year, make and model and color. The only thing is probably the horsepower is much more in sports car, whereas economical car, the miles per gallon is more what you get from it. So I'm going to go and create another class called as sports car, and inside this sports car I am going to say definition, create a function called a display sports self, and I'm going to say print I am a sports car. So this is nothing different from what we created before. The way you can use inheritance is just go to the class definition and you say this belongs to class category. Similarly, I can go ahead and create one more and I can call it eco car, display eco, and I can say equal car, something like this. Now when I create, let's say c2 equal to, I can use the same function because since it's inheriting from car, it's also going to inherit all the functions available there. So I can say this is a sports car BMW, I can call it M5 and it's blue in color. Run this, and now if I say c2 dot display, it will give me the 2004 BMW M5 blue. What if I call c2 dot, the mistake that I did was instead of creating it as a sports car, I created a car, just copy pasted stuff. Run it again. If you see, nothing has changed because sports car inherits from car, so it's going to display. But what if I call display sports function here? It will say I'm a sports car. But what if I call this function in here? It will give me an error because this function doesn't exist in a sports car. Sports car has its own functions, which is this one, display sports, and it has initializers and display car details, but doesn't have economy because economy car is a sister class, and both of them inherit from car. So similarly, I can do something similar with for eco car. I'd say go ahead and try this out and let me know if it doesn't work. I'm going to go ahead and go to the next part of it, which is overriding init methods. What if I want to have a different initializer method for my sports car function? So what I can do is, let me copy this class and I want to add an initializer method for this, which is very much similar to this one. So this is called as overriding your init method. Inside this I have everything same except for I have horsepower. Now I don't have to do all this over again because it already exists in the super class or in the car class. So that is called a super class when you are subclassing. I can say super and I can call the initializer method of that and pass all the things that it has, which is these things, and the only thing that is left is horsepower. Self dot horsepower equal to horsepower. I'm a sports car with horsepower of self dot horsepower. So when I create this, okay, there is some display sports unindent. Okay, so I lost the indentation when I did this. Let me just make sure it's properly indented. Okay, let's try again. Okay, there you go, it worked. Now I'm gonna create C3. I'm gonna call it a sports car and I'm gonna pass everything. Let's 2010 year. I'm gonna say Audi, gonna say model R8, color is white, horsepower is, let's say, 500. Now if I say C3 dot display sports, it will give me I'm a sports car with horsepower 500. And if I say C3 dot the method from my parent class, super class, it will tell me 2010 Audi R8 white. So it worked for both of them. So this is how you can reduce your programming by making sure you write as less code as possible, by separating out what goes in the main class and what goes in the subclasses. Now there's a very common question that everybody asks after this: what if we want to inherit from two different classes? Let's say you want to make a flying car which has properties of both a plane and a car and also has its own properties. So is this possible? So it's a plane and a car, but it's a flying car. So we already have car. So whatever we did till now, where you are inheriting from one single class, is called a single inheritance. Now what the thing that we have in question is, with multiple inheritance, is you are inheriting something from the car and you are inheriting something from plane, and that class is flying car, which is inheriting from two different classes, and that thing called as multiple inheritance. So let's give an example. So we already have a class called as car. I'm going to create a plane class, and inside this I'm going to write a function, plane, let's call it name, which has self and name. Self dot name equal to name, so assign it a name. Next thing, define display plane underscore details and self. So this will display me or print saying I am a plane named comma self dot name. So that takes care of my plane function. Now let's make a class called as flying car. So when I have flying car, that means it's subclasses from car and it's subclasses from plane. Now inside here I can write define flying car name, and I can call it self comma fp name, just to make a different type of variable. Self dot fp name equal to fp name, and define display details self print I am a flying plane. There you go. Flying, sorry, planes fly anyways. Flying car. So I'm gonna make now an object called as flying car 1, flying car. Now I want to give some parameters, but if you see, flying car doesn't have an initializer method, but since it's subclasses from car, that means that I can give it properties like, say this is 2020 and my make is Vivian. I started making flying cars and model is awesome and the color is, let's give a green. That's my flying car. Now if I say fc1 dot plane name, so which means I called a function from car, now I'm calling a function from name. I'm gonna say awesome plane, right? So I can do that too. I can say fc1 dot flying underscore car underscore name. So I'm calling a function from flying car, so I can call functions from anywhere as long as it belongs to either flying car or plane. And this one I'm gonna say awesome car plane. Now if I call fc1 dot display car details function, this will call the function from car class and says car 2020 Vivian awesome green. Next thing is fc1 dot display. As you saw that we can call methods from the parent and the class itself. Similarly I can call plane, let's copy it so I don't type wrong, and it will say I am a plane named awesome plane. Now I want to say fc1 dot display details. This is from here where it should say I'm a flying car. I should have said self dot fp name comma, and then here I can say display details. Let's say I'm a flying car. The reason it didn't work is because when I probably have to run each one of them, there you go, I am flying car awesome car plane. So that's how you can do multiple inheritance, single inheritance, overriding, do constructors, and a lot of things. We did a lot of things here, so I'd want you guys to go ahead and then practice it out, try to understand what I did. If it's difficult to understand, get back to me, write it on the comments. Try to go through all the Python classes that we did here and try to understand what we are trying to get here, because this is very difficult, I understand, but once you start doing some real world projects, that's when you'll understand, and that's what we'll be doing later on in this course. I hope you enjoyed. Thank you for watching, and keep me posted with your questions.